So all along we've been talking about derivatives and they're explicit, right? You get something like y is equal to 5x squared and you just take the derivative with respect to x and that will be your answer. But now we're dealing with a scenario where there's actually two different variables on the same side of the equation. So how do we tackle these type of problems? Again, you want to find everything in terms of dx, dy, dx, right? Everything with respect to x. So basically that's what we're finding. Dx, dy, dx, right? So again, all we're doing is finding dy, dx. So the rule is, or not the rule, but the convention is anytime you take the derivative of a variable, it's always that variable over dx when we're talking about implicit differentiation, and not necessarily all the time dx. It could be in terms of theta. It could be a multiple different variables. So with that being said, let's go on the way. Let's look at some problems. All right. So for number one, again, I will take the derivative of the y of the x, which will just be 2x, right? And this will be dx, right? Because we just take the derivative from the x value, right? We're going to add that again. Taking the derivative of y will be 2y dy dx, right? Notice how my variable changes, and then the derivative of a constant is just 0, right? Now we want to solve for dy dx. Dx could cancel. That's just 1, right? So moving 2x over here, isolating my y, I'm going to have 2y dy dx. And that is going to equal negative 2x, right? Solving for y, right? Solving for dy dx, all I do is just divide 2y on both sides, right? Divide by 2y on both sides, right? And then, right, that will isolate dy dx. And these two will cancel out, right? So my answer is just negative x over y. Right, that will be my derivative with respect to x. Right, let's look at another one. A little bit more complicated, but it's doable. Right, again, this is where we want to apply our chain rule. So this is how I look at it. Right, we want to take the derivative of sine. Well, the derivative of sine of anything is cosine of that same thing. Right, so the first thing I'll do, I'll take the derivative of this one, which would be cosine of x squared y squared, right? And that will be the derivative of x is just 1, right? We still don't have any dy dx yet, right? So what I'm going to do now, I'm going to apply my chain rule, right? So I already took the derivative of the outside, right? I already took the derivative of the outside. Now I'm going to take the derivative of the inside, right? So with that being said, I'm going to say, okay, well, cosine of x squared y squared is going to be multiplied, because remember, when we're taking the chain rule, we got to multiply, right? We're going to multiply by the inside. And this is just a product. So again, 2x, right? 2x dx times y squared. Yes. I could treat this as u and this is v. And if you follow the formula, all I'm doing is saying I'm taking the derivative of u, all right, dx times plain old v, which is y squared, right? And then it's a product, so I'm going to add. And then the rule says, okay, well, I'm going to put my plain old u, which is x squared, multiplied by the derivative of y squared, right? Which is just 2y dy dx. And this is where dy dx comes in, right? And that is just going to equal 1 on that side of the equation, right? Now, I cannot isolate my dy dx, as you could see, because I have a product here. So what I'll have to do is that I'll have to distribute the cosine of x squared, y squared to both of these products. But first, I'll clean up the inside first. So dx is just 1, right? So those could cancel. So this leaves me with cosine of x squared, y squared multiplied by 2x y squared, right, plus 2y x squared dy dx, right? And that is going to equal 1. So now I could just go ahead and distribute my cosine to both of these, right? So this will now be 2x y squared cosine of x squared y squared plus, again, 2y x squared times cosine of x squared y squared. That's going to equal 1. Now, whoa, I forgot my dy dx. Apologize, guys. And this should be dy dx stemming from here, right? So that would be my dy dx. Yes? So now we have an addition right here. So I'm just going to move this over here to isolate my dy dx. So this now will be, okay, 2y x squared cosine x squared y squared dy dx. And that's going to equal 1 minus this over here, which I just moved on the other side of it. So 2xy squared cosine of x squared y squared, right? And then we have a product here, so I'm just going to multiply by this to cancel these out and multiply, well, not multiply, divide, I'm sorry about that. I'm going to divide by 2xy squared cosine of x squared. Maybe I should just do it instead of top on both sides, right? So 2x y squared cosine x squared y squared, right? These go to 1, these cancel, so dy dx will just be 1 minus 2x y squared cosine of x squared y squared, all divided by 2x y squared cosine of x squared y squared, right? This will be my answer.